Swayam Prabha. Digital India. Educated India.
Optimization, you guys, even you have sophomore, you can do this optimization. dp dc dp dk equals 0. You find best C, best P. But find best C, best P, you wouldn't be able to publish the paper, right? This is high school, so not high school, sophomore can do such kind of exercise. You need to look into one step more. What's the one step more? Physics inside, right? Here, physics inside was that, oh, Y is best. Okay, the physics inside is still matching the frequency, right? So research is not just, okay, I get this work done, I summarize the system, therefore I can send my paper to publish. Yes, maybe you can. Nowadays, so many journals, right? As long as you write anything out, you can find some publisher is willing to publish your work. Sometimes you just need to pay money to publish, right? And I don't like that. I never pay money to publish. Okay. Sometimes they have open access. Invite me for the paper. I don't send the paper there, and occasionally I have some friend who organize special issue. I need to support my friend. When he invited me to send a paper there, I said, if you can waive my publication charge, I can send one paper to you. So if you don't waive my publication fee, whatever, I wouldn't be able to send to you. I even have money, right? Other research, I create knowledge, I want to share with others, right? Instead of creating knowledge, I pay to share with others. Yeah. Anyway, this is my personal opinion, and probably in European countries, open access journal is very, very well respected. But in American culture, people don't like open access. Anyway, so now I want to give you sense. You guys can make contribution to the research. Just need to have some physical understanding. Just need to a little deeper, right? Another sense, the research is you need to have fixed insights here, right? Instead of, okay, I designed this system, right? But you didn't know how it works, right? Now you can say several examples we went through, right? We want to match the frequency. We take advantage of the added mass, right? We take advantage of the PTO's damping. Basically, we try to cancel the stiffness effect and also the mass effect. After that, we only have damping term, in which the damping force is the same direction, always in phase with excitation. In that way, you take maximum power out. Okay. However, such kind of maximum power is a mechanical power. It doesn't mean output power. So when we design the PTO, we need to consider this type of efficiency. There are two steps. Wave energy, kinetic energy of the water, potential energy of water, convert into mechanical energy, right? This is one step. Second step, this mechanical energy drive a generator, convert this into electricity. Okay, so electricity is very, very irregular thing. We need to power electronics to regulate the power and control the impedance so that you maximum power output. So Monday's lecture, I'm going to talk about PTO design. I also going to talk about the output power. You will find that in some case, you maximize the input power, the output power is not the best. And also, Tomorrow's lecture we are going to talk about alternating water column. Alternating water column is not a moving mass, and it's bucket upside down, and the water surface move up and down. Okay, and initially I prepared two lectures on that, on the alternating water column. I'm going to reduce that so that I can cover a little bit on something beyond the engineering side, like environment, like tech, economic analysis. But wave energy conversion is not that complicated, just spray mass system. The only thing is the spray mass is special mass, you have added mass, and special damper, radiation damping, right? So you just need to have some physical understanding. Yes, questions? So next week I'm going to give a seminar. This seminar probably half will be same as my first lecture, and I will talk a little bit more than that. Okay, wave energy converter itself really multidisciplinary. You need to think everything, right? Just imagine that way. I show you this type of thing. Look like interesting research, right? And really need to put there water leakage, right? We put a PTO inside here. This piston this ball screw drive this shaft, drive a ball screw inside, and this part water leakage. When water leakage happen, we have to take things out, drain up everything, right? So anything small mistake, you create a lot of problem, right? And this is why a lot of wave energy converter company, before they put things in the water, wow, they can excite many people to invest them. But once they put it in the water, man, you sunk into the water, then the company shut down, right? So a lot of time is really there. I would say a lot of time it's just a very minor problem. For example, one company, they developed this type of wave energy converter. They didn't put the modern than where. Okay, let me tell you, go to this. I don't want to mention the company's name here. So let me go to the page here. Okay, they designed this type of system. They put modern line here. Single line modern line. So single line modern line here when storm happen, twist, then eventually the cable broken. Okay, and tear this off, then water leakage get into that, then this thing sunk into the water, right? So we didn't get chance to tell you modern line. Did you see this modern line here? We didn't put this bottom side. The best modern line, you put it close to the gravity center or buoyancy force center, right? If you just put there, this sense, like this type of motion, this modern line force will be small, but you put here, it will be something like that, right? So anyway, and you have good point, and what's the challenging in the wave energy converter? Okay, I would say reliability, efficiency, or survivability, right? And cost. Eventually, cost drive. Money talks, right? You need to convince people you can invest, you can owe money, right? This venture capital guys give you money, you say they can get the money back. You need to convince the utility company, yeah, use my wave energy converter is much cheaper than the solar, than the diesel engine, right? This is technical economic analysis, you need to look into that, right? The survival in the water, in the harsh environment, that is something we need to take care of that. And then overall, the efficiency, that is way to drive the donors per kilowatts numbers more. In the tank, people can show that, as I mentioned, the wave capture ratio can be 1. right? And it doesn't mean that is the best, right? So wave capture ratio is the first stage, and second stage is PTO efficiency, right? You as I later I'm going to talk about control core design. You will find some case study. You have more power input, but you may have less power output. Yeah. Another thing is you use the word the best. What's the best? What's the metrics? How to measure which one is best? When you design that, what's the best? I just mentioned that eventually donors per kilowatts, right? But donors per kilowatts, you design very, very cheap stuff. Just imagine that way. For the extreme case, the community wouldn't buy that, right? They said you put there, I just don't like that because in my backyard I don't want to see this motion at all, right? The community engagement is important, right? Or the government said, okay, they didn't give you permission, whatever like that. This policy, society, all these are important. Also environment, right? So which one is the best? Also this device need to share with the water is not, usually no one owns the water, right? Most of the case, this water is shared with others, right? You put your device, you say, oh, this beach area, we have very large wave. I want to put the device there. The beach user, they said, no, no, you cannot put it there, right? So what's the best? Right? You need a really, really multi-dimensional metrics to evaluate which one is best. Right? In one project we are working on, actually, Vishnu, Professor Samuel's master student, he is leading. We try to evaluate which one is best. We develop metrics to say one is donors per kilowatts, right? And another is environmental impact, right? Or third dimension may be technology readiness level. We don't know yet. We want to say which one is the best. Yeah.
Sir, my question is,
Point observers, like in literature review, most of the time we see the boys or point observers are actually like he motion is considered mostly. And this what surge converters, when we come to the surge converters, the capture ratio is more compared to the heave. But then that I find that that is more like when compared to the heave and the surge converters, these are the more I find in the literature. And surge, what is the reason?
Okay, you are very right. Okay, point observer overall, the overall efficiency in the literature, right, is some paper shows a single digit, right? Some people say we can get 10% will to wear efficiency, will to electricity efficiency, right? And for our study in a tank, we get will to wear efficiency only 20%. It's not that high. Its descent is not that high. And for this device, for example, the capture width ratio can be 60. This can be 20 or 30, right? This is already much better because out of phase motion. However, and this is capture width ratio PTO, time PTO efficiency, this overall efficiency, right? Where the wave surge device, you can say people can have 30%, 40% will capture, no, is will to wear efficiency, right? So they are different. And I would say the working principle from a certain level perspective is significantly different. And for point observer, you highlight resonance, right? You can really say the excitation force at certain frequency you can be large. where wave surge device, resonance is not that important, right? Overall, this system is hard. Over different damping, right? This mass, huge mass, and just follow the motion. Which one is the best? We don't know. I give one example, okay. And if I want to develop something to monitor the ocean, I just need to have 50 watts energy. Because for such kind of application, right, and I would think point absorber is easier to design, easier to maintenance. Instead of you have floating Indian Ocean, right, floating mooring, you have this type of thing, right? So you another example, you want to have seawater desalination, right? You seawater desalination clearly, you don't want this put this buoy 1 kilometer away from the place you need the water, right? You most like close to the shore, then wave surge device might be good one. Or even you have such kind of arm system you mount on the land, this is more up and down, right? So all this application, I would say application oriented, you need to find the market first, or and you define the user first. With this user in mind, you can choose the best design for particular this application. Is clear? Yeah. You mentioned the two point absorber and wave surge device. There's another popular is alternating water column. And the system in operation so far, like more than 10 years, some device, more than 20 years device, most of such kind of device are alternating water column. Yeah. Alternating water column, they can build on land, right? So, and airline-based company, Ocean Power, Ocean Energy Buoy, they also build floating, yeah. Any questions?
Sir, are there any other techniques? Here we use the heat point observer, there is surge, and now you are telling about the wave water column, oscillating column. Are there any other techniques?
Submerge type. Submerge. Some device totally merge into water, right? And one typical company, Australia-based company, Carnegie Power, okay, is submerged device, right? And the first utility scale trial is this type of device, right? Like ocean snake, they use that to draw the piston. So there are over 1,000 different designs, right? So because we don't have good evaluation metrics, we don't know which one is best. Right? We push very hard, try to say which one is the best. We try to say how to design which one is best by integrate engineer in mechanical engineering, ocean engineering, civil engineering, electrical engineering together, and social scientists, right? Environmental scientists, community together. Yeah. So I would say this is wave energy field, the playground is large enough, right? Everyone can jump in. Everyone can jump in from different perspective and take your background into this field, right? Keep mind open for the collaboration. Don't think, wow, I have this design, this is best. Therefore, I put my effort 100% to drive this. I like this type of momentum driven, but meanwhile you need to say, oh, well, this may not be the best, right? I need to make some change. For example, I give you one example. U.S. company and car wheel. Car wheel start from UC Berkeley is one concept, carpet, wheel carpet. Wheel carpet radar realize the phenomenon, and it's one beach area. One side is mud, another side is rock, and wheel come in. You can say the system with mud or seabed, the wave get damped, and this wave is high. So he got an idea, why not we put such kind of carpet as wave converter and it harvest energy, right? And they started this concept, we go through the DOE's wave energy price competition, right? They go through this competition, they won the competition. I forgot this, I think this is number 2. After that, DOE gave them $4.7 million to develop the commercialization, near commercialization product. You look into the company's website, they are not wheel carpet anymore. So it's a nice idea. They can convince sponsor to give them money, but you have to keep your mind open. During the working process, right? You find some reason to say, wow, yeah, this is a nice idea, but there are some constraints. Whether what kind of constraint these guys change the market, they redefine the product, they wouldn't tell you, right? But at the same time, from themselves, they are convinced that wheel carpet, there are some constraints. Therefore, we have to change research direction. Open-minded collaboration is important, right? And we have to accept that our knowledge is limited, right? And we give some space to other people to give the input and team up together, open accept other suggestions. Yeah.
So you said, like, compared to the RN3 to body model, that UDUF is better.
Yeah.
Because it can move in the out of phase both the bodies, and we can extract maximum power. What is stability? Isn't there is a trade-off between stability and the power extraction?
Stability is fine. You can design for that. It's just a buoyancy force center, and for this one, some modular body is not like a boat. You have gravity center there. So this one is more like a CG and a BG, buoyancy force center. And I told you another thing. Maybe this one is not best. Why? So you just even imagine that way cost, right? And the reference model 3, the plate is just one plate. The cost is no. Where the second part, you have to build a tank, right? You need to take economic analysis to say not only power output, right? You double power output, whatever. What if you triple the cost? That's bad, right? You double output, then you increase the cost by 50%, you gain, right? You triple the cost, then this is not the best, right? This problem, you can look into that. We did some study, but I'm not convinced about the result yet about technical analysis for the design, yeah.
We are designing this energy converter now. We are not considering the chemical property of the water. It is considered the seawater chemical properties.
What kind of property?
Like oil and all other chemicals are there in water.
Yes, you need to consider that, right? For example, the corrosion, the biofouling, right? So, for example, you have wave energy converter like that. You take this example, right? You want to have streamline shape. You want to have smaller drag. But what if muscle, biofouling, seaweed grab on that, right? Then quickly you have huge drag. Then your system may not work, right? All the type of thing you need to consider. So far, people use paint, right? The different paint, different material to reduce biofouling effect, right? Also, corrosion is important, right? And stainless steel, you think is nice at home refrigerator. That's new building. You can say another stainless steel. In the water, you put stainless steel there. Outerwear, corrosion happen, right? So once I discussed with one more engineer, he said, I didn't say stainless steel in the ocean, and it corrosion happen, right? So you need to save different material to reduce friction. No, reduce no friction, the corrosion, right? This is why one student mentioned about concrete, and I said, okay, maybe we can use concrete to build this device, right? Concrete normally is more resistive to the chemical corrosion, right? Any other question?
Concrete, biofoiling will be one issue.
Biofouling. It's true. Probably mass like concrete more. I saw.
Telling about that fruit number and Reynolds number.
Yeah.
So, the last you were telling like similarity we should be taking.
Yeah.
So, if we consider only fruit number, if we ignore that viscosity or something, the turbulence and vortex will be more, and that we can't ignore that. So, how that similarity could be taken and how that effect will be
Okay.
there.
No, let me say that way. And for the wave energy, so far the linear wave theory all developed based on the potential flow, right? For the potential flow, there's no viscosity, right? Reynolds number is inertial force divided by viscosity, right? Therefore, when we develop wave energy converter, there's no need to consider Reynolds number. Make sense? Because all this added mass radiation damping is potential flow. So there's no viscosity, right? However, it doesn't mean we don't consider viscosity, right? This is why importance then we say reduce the drag. We talk about the drag fluid separation, streamline shape, right? So the purpose to reduce the such kind of drag or viscosity damping. Yeah. So you cannot keep both. For example, you scale up, scale down sense, right? Just to look at this one, and the velocity. Let me see this figure. Right, you have velocity dimension, right? So and mu, right? You cannot keep both. I would say that way. You scale down sense up and down using Freud number, but the non-ideal case viscosity and the impact wouldn't scale down linearly, right?
So, but for energy conversion, that thing is okay. So, but when we are considering about the structure, we also need to consider about the structure stability, likewise. So, will it affect that?
Similarity, yeah, is true, and Freud number keep similarity and without consider the viscosity, right? And therefore, you have some shape you design like that, you know it will generate or not a vortex. You say in such kind of case, Freud number this scaling you cannot scale up, right? So like the flap, the type of shape, how to handle this edge, right? You don't want to have sharp edge like that, yeah. Okay.
This design is based on linear theory. Are there any designs based on higher order theories, or this is enough for now technology?
This is not enough. Okay, this is first order design, right? Linear wave series first order design. After that, you use high fidelity simulation to confirm the design, right? Okay.
Are they based on higher order theories? Are they designed numerical design? Are the
When you
simulations
talk
different?
about high order nonlinear system, you are talking about a different domain. One is computational fluid, right? Another is control, right? For all this control, I say this is PTO stiffness, PTO damping, right? Right. I use K, P, KC, right? This is linear system, right? You can use nonlinear design too, right? So computational fluid side, I say first order design, potential flow, and then you have more Navier NS equations, this type of based validation. And the control side, you can have this very simplified KC, you can have more complicated controller, right? Dynamic side, you may have linear spring, right? You may have nonlinear spring, and overall system, and you get the first order design get done, then take advantage of high order system, right? High order system, there's an advantage, especially for wave energy is important. Wave energy linear design is done, but you cannot stop at the linear design. The reason is the wave energy converter eventually practically is not linear, right? They will just say, okay, we set the wave amplitude is smaller than the size of moving body. Mostly, you put a buoy there 2 meters, 1 meter, the wave itself is already 1 or 2 meters, right? Another linear assumption wouldn't hold in real life. Therefore, your design cannot stop at the linear level. Yeah. One last question. Almost one last question. Okay. If no question, we stop, and tomorrow we are going to continue talk about alternating water column or third popular type, and also environment and RCOE. Okay. RCOE is monotonous per kilowatt. Yeah. Thank you. Yeah.